Good day, students, and welcome back to the next lesson on the principle of moments. This is example number 2. There we have a lever. Now let's call this lever lever CB. Okay, lever CB. Point of rotation is at A. The question is determine the moments about point A. Okay, there's 3 forces there acting about point A. We can start with any one, doesn't matter, but we need to take them all. I'm going to start from the top down. Okay, so I'm going to say the sum of the moments but A is equal to, right, there's my point of rotation, so that force, it's acting to the right, but it's going to give a clockwise moment with respect to A, so it's going to be positive, so it is 20 times, and I didn't give it a distance. Let me call that 1.8 meters there. Let me call this 2.3 meters over here. Okay, so that's 2.3 meters, 1.8 meters. So it's 20 times 1.8 plus. Right. What's the definition of a moment? Force times distance. This force here, are you tuning in? This force here acts through the point of rotation. What's the distance from the lever arm to the point of rotation? It is 0. Okay, and anything times 0, 0. Okay, so therefore that force has no moment effect about A. But for the first time and the only one time, I'm going to say 30 times 0. That's the only time I'm ever going to say that. Okay, so any force that acts to the point of rotation or the hinge or the fulcrum is 0. Right, this force here, this force plus or minus about A? This force will give an anti-clockwise moment with respect to A, so it's going to be minus. Okay, right. Now, what's a moment? A moment is a force multiplied by a perpendicular distance. This distance here is the distance at right angles to the line of action of that force there? No, it's not. So, you can either do it one of two ways. Okay, you can either resolve this force into its components, like so. You can either do this, or you can do that. Okay, and take the moments of those two forces about that point there. But I'm not going to do that just yet. Okay, so let me just take that away. Right, what I'm going to do is this. Now, what we're going to do, we are going to draw a line. I'm going to draw. Now remember, a moment is a force times a perpendicular distance. I'm going to draw a line through the point of rotation at right angles to that line of action there. I'll say that again. I'll draw a line through the point of rotation at right angles to the line of action of that force there. Okay, and that little distance, let me just change that. And that length of that line there, little d from there to there, is the lever arm form of 40 Newton force. Okay, do we know what it is? No, we don't, but we can work it out because we now have a right angle triangle, right? So the question is, there I have the hypotenuse of the triangle, which is 2.3 meters. I have an angle inside there, which is 50 degrees. The question is, what trig ratio must I use to find little d? And what trig ratio are we going to use? I think we are going to use the sine. I'm going to do it here. The sine of 50 degrees is equal to small d over the hypotenuse, which is 2.3. Therefore, small d is equal to 2.3 times sine 50 degrees. Okay, right. I can work at the answer, but I'm going to use it as it is, because when I'm going to use this in the calculation there, because I'm only going to work it out there, I'm going to get a slightly better answer. Right, let's take moments. Right, so that's going to be minus 40. There's my minus 40 times little d. But little d is 2.3 sine 50, so it's 2.3 times sine 50 is equal to, right, and get your calculator and you work out the answer. And you should have done the calculation. The answer I get is minus 34.48 Newton meters. Why newtons? Because all forces in newtons and all distances is in meters. Okay, so it's minus 34.4 Newton meters. And what does the minus sign mean? It means that the lever is actually going to turn in an anti-clockwise direction like that. Okay, right, so that's how we done that one there. But let's just say that we're going to resolve this one into components, as I spoke of earlier, and use those forces to take moments about A and compare that answer with that answer. We should get the same answer. And let's check it out. Right, I'm going to resolve this into components. So there's going to be a force there, and there's going to be a force there, like so. Right, that angle there is 50 degrees. So that component is 40 cos 50. 40 cos 50. And that's going to be 40 times the sine of that same angle. 40 sine 50. Right, let's take moments. I'm going to say the sum of the moments about A is equal to, that's still going to be plus 20 times 1.8, plus 20 times 1.8. That's going to be 0. I'm going to leave it out. Right. Now remember, these two forces here, so when we take moments, we either take the 40 or, did you hear the word or those two there. So we either use those two forces in the moment equation, or we use that force in the moment equation. We can't use all three. That'll be wrong. Okay. Now, this force here, remember these forces are actually acting through that point over there. So that force is acting like so actually, and that force is actually acting like so. Okay, they're actually acting at that point there. Now, this force here, which is 40 cos 50, can you see it's actually acting through the point of rotation? So it's going to be equal to 0. That's right. So this one here, so only this one of the two components is going to have an anti-clockwise effect about A. So it's going to be minus 40 sine 50, 40 sine 50. Remember that there's the force. That's only the force. What's the lever arm? The lever arm is 2.3. 2.3 is equal to. Okay. Right. Now, just check here. We're not going to even work it out. That is the same as that. Okay. That's 0. And can you see that 40 times sine from that day is the same as all of that over there? Okay. If you want to, you can work it out. But it's going to come to the same answer, which is going to be minus 34.48 Newton meters. And that's the size of the moment. It's negative. So that means that lever BC, is going to want to turn anti-clockwise. So I've taken moments about point A using the 20 and the 40 Newton force. That's going to be 0. And I've taken moments using about point A using that force and the components of this force here. But because this force is acting at this point here, this force goes to the point of rotation, so it's going to be 0 as well. And that force is acting over there, and that force is equal to that force is equal to 40 sine 50. Its lever arm is 2.3. Work it out, comes the same as that. And therefore, so when you take moments about the point, you can either use that method there, or you can use that one there. Okay, so people, that's the end of the second lesson of Principle of Moments.